Good afternoon, children. We will start the last topic in this chapter of reflection and refraction of light, which is called power of a lens. Power of a lens we will discuss in this section today. So, yesterday I had told we discussed various numerical problems about the focal length I told and how to use the sign convention in the case of object distance, image distance, positive sign, negative sign, everything we discussed, and we did two numerical problems on that. We discussed two numerical problems, and I hope you came to know, and still more problems are there. We will be discussing later on. Okay, children, of different types. Now, what do you mean by the term power? So, the ability of a lens to converge or diverge the light rays. Convex lens converges the light rays. We had seen with a ray diagram. But whereas concave lens diverges the light rays. With one more ray diagram we discussed. Okay, children. So the ability of a lens to converge or diverge the light rays is called as its power. So the lenses which are having shorter focal length I mean the distance between optical center and principal focus. The light rays converges there after undergoing refraction in the case of convex lens. But in the case of concave lens, it appears to diverge. So the ability of that lens to converge or diverge the light rays is termed as power of a lens. So, and one more thing, power is different. So it is expressed in the unit which is called as diopter. One diopter is the power of a lens whose focal length is 1 meter. One diopter is a power of a lens whose focal length is equal to 1 meter. The power of convex lens is positive, but whereas the power of concave lens will be negative. So we will take down the definition of the power. The power of a lens is defined as the reciprocal of its focal length. Definition. The power of a lens is defined. The power of a lens is defined as the reciprocal of its focal length. Focal length. The power of a lens is defined as the reciprocal of its focal length. It is denoted by P. It is denoted by P. So how will you write the power? P is equal to 1 by F, which is expressed in reciprocal of its focal length, and like this you can denote. Power of a lens is denoted by P is equal to 1 by F, and it is expressed in meters. The focal length will be expressed in meter. If he is giving in centimeter also in some problem, you must convert into meter. Okay, children. So P is equal to 1 by F. This is the formula to find out the power of a lens, and the SI unit The SI. Nowadays we are all using SI only, System of International Units. Okay, children. The SI unit of power. The SI unit of power is diopter. The SI unit of power is diopter. So this is the symbol D. D is the symbol. The SI unit of power is how it is expressed in diopter. One diopter is the power of a defined diopter. If it tells, how will you define it? One diopter is the power of a lens whose focal length is 1 meter. One diopter, take down this, one diopter is a power of a lens whose focal length is equal to 1 meter. One diopter is a power of a lens whose focal length is equal to 1 meter. So how will you represent it symbolically? 1D is equal to 1 per meter. So like that you can express. So 1 diopter is equal to focal length which is expressed in meter. The focal length will be expressed in meter. So power of a lens is defined as a reciprocal of a focal length. One diopter is a power of a lens whose focal length is equal to 1 meter. It will be expressed in meters. So often a lens is having plus 2D. The power of a lens is representing as plus 2D. That means the power of a lens is plus 2 diopter. So positive, the power of a convex lens is positive, and whereas the power of a concave lens is taken as negative. Okay, children, write down. Power of a convex lens is positive. Power of a convex lens is positive. Convex lens, if plus comes, you must think it is a convex lens. Which type of lens is used, you will ask. So if positive, plus comes, positive. The power of a convex lens is positive, and the power of a concave lens, the power of a concave lens is negative. The power of a convex lens is positive and the power of a concave lens is negative. If plus comes, you must think it as a convex lens. If minus comes, you must think that as a concave lens. Its power is negative, means concave lens. If its power is positive, it is a convex lens. So usually many optical instruments, we are coming across many optical instruments like microscope, different types of lenses, telescope. They are all designed by the combination of lenses. They are made by the combination of lenses. 2-3 lenses joined together form the optical instruments like microscope, telescope, camera and all. So they are having different powers. So opticians use different power of a lens and to design different optical instruments having different powers. Let P be the net power of a lens and P1, P2, P3 will be the combination of the powers. So the net power P is expressed as P is equal to P1 plus P2 plus P3. Okay, children. To design, we must use the different powers of the lenses. Okay, so the net power P of the lens placed in contact, the net power P, the net power P of the lenses placed in contact, P of the lenses placed in contact, is given by the algebraic sum of the individuals is given by the algebraic sum of the individual powers. So how will you represent this, children? P is equal to, hence P is can be expressed as P1 plus P2 plus P3 plus so on. Write this much in the box. So the net power P, if he is giving different powers, for example, so you should add everything. It is the algebraic sum of the individual powers. For example, the power of one lens is, the power of a lens is 2 diopter. Power of P1 is 2 diopter, and power of a lens P2 is 0.25 diopter. So like this, if it is given, the power of a lens P1 is 2 diopter and the power of the lens P2 is 0.25 diopter. So what will be the net power here? Net power P is equal to algebraic sum P1 plus P2. So it is equal to simple addition 2.0 diopter plus 0.25 diopter. So it is equal to 2.25 diopter. So like this you should find. The net power P is equal to P1 plus P2, which is equal to 2.0 diopter plus 0.25 diopter is equal to 2.25 diopter. Like this you can understand the power of a lens. Okay, children. Now we will move to next concept. We will discuss some of the in-text questions. We will discuss some of the in-text questions now. So this net power P1 is equal to 2.0 diopter, and if P2 is 0.25 diopter, then the net power, just now I told no, the net power is given by the algebraic sum of individual powers P1 plus P2. 2.0 diopter plus 0.25 diopter, simple addition, so it is 2.25 diopter. So after understanding this much about the power of a lens, we will solve some of the in-text questions. Okay, sir. Write down the heading in-text questions. Intake question. First one, write down. Define 1 diopter of power of a lens. Define 1 diopter of power of a lens. So he is telling you to define 1 diopter of power of a lens. So how will you define? The SI unit answer. The SI unit of power of a lens. The SI unit of power of a lens is diopter. So, 1 diopter is defined. 1 diopter is defined. 1 diopter is defined as the power of a lens. As the power of a lens. 1 diopter is defined as the power of a lens of focal length 1 meter. So it is defined as the power of a lens of focal length 1 meter. Now, next question. Write down. A convex lens forms a real and inverted image. A convex lens forms a real and inverted image. A convex lens forms a real and inverted image of a needle real and inverted image of a needle at a distance of 50 centimeter from it. At a distance of 50 centimeter from it. At a distance of 50 centimeter from it. Where is the needle placed? Where is the needle placed? Where is the needle placed? In front of the convex lens. In front of the convex lens. In front of the convex lens. If the image is equal to the size of the object. To the size of the object is equal to the size of the object. A convex lens forms a, just now in so many ray diagrams we had studied already, that always a convex lens produces a real and inverted image of a needle at a distance of 50 centimeter from it. Where is the needle placed in front of the convex lens if the image is equal to the size of the needle? So we have seen in one of the ray diagram, children, according to the rule 1 and 3, if it undergoes refraction, which is at a distance, the needle at a distance of 50 centimeter from the convex lens forms a same at the same distance forms a real and inverted image at the distance of 50 centimeter from the lens. Both are equal in size eters. So it undergoes refraction and an image is formed at f2. Okay. So that only you should write. Since the image is real and same size, since the image is real, since the image is real and same size, since the image is real and same size, the position of the image should be at 2f. The position of the image should be at 2f. It is given that the image of the needle is formed it is given that the image of the needle it's given that the image of the needle is formed at a distance of is formed at a distance formed at a distance of 50 centimeter from the convex lens hence the needle is placed in front hence the needle is placed in front of the lens placed in front of the lens at a distance of 50 centimeter. Lens at a distance of 50 centimeter. So what will be the object distance? So object distance, here I am writing object distance from the lens it is u is equal to minus 50 centimeter. Image distance v is equal to 50 centimeter. So like this we will conclude this answer. Okay children, take down. Now the next question. Find the power of a concave lens of focal length 2 meter. So write down this answer. So since the image is real and same size, the position of the image should be at 2f. It is given that the image of the needle is formed at a distance of 50 centimeter from the convex lens. Hence, the needle is placed in front of the lens at a distance of 50 centimeter. So, hence both are same. The object distance is from the lens, we are taking it as minus 50, and image distance is from away from the lens. So, it is how much? 50, V is plus 50 centimeter. Now, question number 3. Write down question number 3. Find the power of a concave lens. Find the power of a concave lens. Find the power of a concave lens of focal length 2 meter. Of focal length 2 meter. So we must find the power of a concave length, focal length he has given. We should find the power of that. Answer. Focal length of concave lens is equal to 2 meter. Focal length of concave lens is equal to 2 meter. Now, power of the lens. Power of the lens P is equal to how much? Since we know that since we know that P is equal to 1 by F. 1 by F. So, I told in the beginning, concave lens means minus power. 1 by minus 2. Everything is just you divide it. 1 by minus 2 is minus 0.5 diopter. So it is, if you divide, it will become minus 0.5 diopter. Therefore, power of the lens, power of the lens P is equal to minus 0.5 diopter. So this is how you must find the power of a lens. Minus 2, if you divide it, it will become minus 0.5 diopter. Power of the lens P is equal to minus 0.5 diopter. This is the power of a lens. Okay, children. So like this, it is possible for us to calculate the problems which are given on power of a lens. Now after this is the end of this chapter. A very big chapter we have concluded on light, and we will do the questions on exercise. Okay. We'll do some exercise questions. So we will do the exercise. Exercises, you write. Which one of the following materials? First question, write down. MCQ it is. Write all the options. Which one of the following materials which one of the following materials cannot be used which one of the following materials cannot be used to make a lens? To make a lens. So which materials we are not using to make the lens? Okay, children. Here 4 options have been given. So we will mark the correct option only. A is water. Water. B is glass. C is plastic. D is lead. So understand the question properly, children. What he is telling? Which one of the following materials cannot be used to make a lens? Of course, we can use water, glass, plastic, but clay we are not using. So which of the following materials cannot be used to make a lens? The correct option is D. So mark D option, clay. Okay, children. Now we will move to second question. The image formed by a concave mirror, the image formed by a concave mirror is observed to be virtual. Is observed to be virtual. Is observed to be virtual, erect, virtual, erect, and larger than the object. And larger than the object. Larger than the object. Where should be the position of the object? Where should be the position of the object? So write down the options, children. Between the principal focus and the center of curvature. A option, between the principal focus and the center of curvature. Between the principal focus and the center of curvature. What is B option? At the center of curvature. At the center of curvature. What is C option? Beyond the center of curvature. Beyond the center of curvature. Beyond the center of curvature. What is D option? Between the pole of the mirror and its principal focus. Between the pole of the mirror and its principal focus. Between the pole of the mirror and its principal focus. Now, which is most appropriate option? We should think and mark it. The image formed by a concave mirror is observed to be erect and larger than the object. Where should be the position of the object? So many ray diagrams in case of concave mirror we discussed. Okay, children. So where should be the position of the object he is telling me? Between the principal focus and the center of curvature? No. At the center of curvature? No. Beyond the center of curvature? No. Between the pole and of the mirror and the principal focus. Between P and F. So this is the correct option. D, mark D. So this will be the correct option. Okay, sir. Now question number 3. Where should be an object? Third one, write down. Where should be an object? Where should be an object? Where should be an object placed in front of a convex lens to get a real image of the size of the object. Of the same size of the object. Here you see, where should be an object placed in front of a convex lens to get a real image of the same size, or size means same size of the object. Here some options have been given. At the principal focus of the lens, A option, at the principal focus of the lens. B option, at twice the focal length. At twice the focal length. C option is twice the focal length at infinity. C option is at infinity. B option, between the optical center of the lens, between the optical center of the lens, between the optical center of the lens and its principal focus, and its principal focus. So, where you feel is the correct answer? That we will discuss here. Where should be an object placed in front of a convex lens of to get a real image of the same size of the object? At the principal focus of the lens, at twice the focal length, at twice the focal length, or at infinity between the optical center of the lens and the principal focus. So in this case, the correct option will be B1, at twice the focal length, at 2f. Mark B1. So this is the correct option, at twice the focal length. At 2f, the image, real image should be formed at 2f, which is real and inverted, of the same size of the object. You can refer the ray diagram, you will understand that if you place the image is formed, if you place the object at 2f, you are getting the image also at 2f, which is of the same size, Okay, children. So, question number 4 we'll discuss tomorrow. Tomorrow we'll discuss question number 4. Okay, children. So try to note down everything. Okay, thank you.